Okay, in this video we're going to do a couple mil relation formulas. This one is target size in inches to target range in meters. So the target is 5 foot 6 inches tall, measured at 2.5 mils. The real formula is 5 foot 6 inches is 1.67 meters, times it by 1,000 equals 1,600. Divide by what you measured in mils, gives you the meters. On the back of the F.I.R.E system, 5 foot 6 inches is 66 inches tall. So 66 inches tall, you put under the number 1. That's always a starting point, set in the disc, just like on the front side. Go to the outside until you see 2.54 or 25.4, one and the same. Comes out to 1.67 more or less. 5, 6, 7. Take that 167. The actual number is relevant, so you take 1.6 plus 2. 2 lines, doesn't really matter what it is. Rotate that under how many mils? 1.67 under 2.5 mils. Go back to the top, and that gives us about 670 meters more or less, which is the same thing as up there. So it's target size in inches, 2.54. Take that number, put under how many mils, happens to be 2.5, close. Back to the top, that's how many meters the target is away. Next one will be a target range in meters to target size in meters, which is exactly the same thing. Instead of going to the 66 inches to start, we already know the size in meters is measured out already, 1.67, 1.7 meters tall. You put that 1.67 under the 2.5 mils, and 650, 655, 660, right there, 670 meters. Same thing as the other one, just target size is already converted to meters instead of starting out in inches. Here we go. We already know the distance, but we want to find out the actual size of the target. We know the target range is 670 meters. We lased it, or we already know something at that distance. We measured 2.5 mils in the scope. Target range in meters under the number 1, which sets the disc, so 670. Find the target size in mils on the outer scale. We know measure is 2.5. Take that number, place it under number 1, resetting the disc. 1.67 under the number 1. Find 3.93, which is really 39.3, but you move the decimal mentally. 39.3 gets us back to that 66-inch mark, which is what is there. So it's really just in reverse, but if you don't know the target size, so you wind up starting out with the range, set the disc, don't rotate, mils, 1.6, 1.65, 66, 67. Take that, spin that up, 39.3, 66, 67 inches. Once again, you could be off by a little bit. One of the benefits of this, you can be off by just a touch, and the target is 1 inch taller or 1 inch further, or the distance is 5 yards less or 5 yards more, which realistically that's 100% irrelevant, which just aids in the speed, not worrying about that exact spot on the tool itself. Another thing we can look at is moving targets. It's all about the same. It's a 1 or 2 step math problems on the back of this. We'll go with the same distance. Target range is 460 meters. Time of flight at that distance is 0.6 seconds. And we tracked the target. He moved 3 mils in 1 second. So the simple way to go is 0.6 seconds times 3. 6 under the 1 for 0.6. Rotate around until you see 3. 1.8 is 1.8 mils. So it's really as simple as you get. You can do, or you can do how many mils you traveled since this multiplication. You can flip it around. How many mils it traveled. Then you go by 6 for 0.6, and it's 1.8 again. It's all one and the same. So really, whichever one you want to do first, however you want to set it up, it's one and the same thing. You could also use the front of it, the wind full value conversion. If the target's walking away on a 45, and you actually want to know the speed of the target, not for lead, but for relaying information. If you caught it 3 mils, you can use the wind numbers the same as the as speed. It's one and the same. It's still this one is still 50%. So you'd set how many mils you caught, 1, 2, 3. That's what you saw on your scope as you're watching. Realistically, it's doing 6 mil speed because it's walking away on a 45. You're only counting this distance. You're not counting the linear distance when you're looking through your scope. So you can use this front side for conversion of actual target speed if needed, not only for the firing solution. And one more. This one's probably a little more specific, but team of 2, you have a forward observer, a different location than firing position. The forward observer is about 100 meters from the target. The sniper or firing position is 2,000 meters from target. After shots fired, the forward observer calls a splash 5 mils left of the target. So the forward observer has to calculate and communicate the correction because the firing team couldn't see it. So the math is 5 mils times 100 divided by 25.4 equals 19.7 inches, so 1920 inches. What we're going to do, we're going to do it on the backside, one and the same. So we have 5 mils, 5, place it under 25.4. Answer 1.97, 19.7 inches. Once again, we're going to decimal place, but you know it's not 1 inches, and you know it's not 190 inches, so it's pretty easy. And if you're off by that much, if it's 19.5 or 19.8, it doesn't really matter if you're relaying to a shot 2,000 meters away. That's if you want to relay it in inches. If you want to relay it in mils, so the same thing, the photo observer would say, okay, you missed by 19.5, not going to count that tight, 19.7 inches. You'd set it to 19.7. You'd find the same 25.4. That would give you 5, which is mils all of a sudden. That's 5 mils, 100 yards. You'd place the 5 mils under 2 for 2,000 yards, sorry, 2,000 meters. Look under the number 1, it'll give you a 0.25 mil adjustment. 0.25 mils, that distance would give you the same center hold again. So you can relay it in inches or you can relay it in mils. It's really the same thing, it's just whatever number you start with. And you see the benefit of not having, even if you're not exact, 2.48 or 0.248 or 0.252 mils. Nobody's dying or holding that close. So once again, you see the ultimate accuracy is not needed because the clicks on the scope or the hold we're going to do is not that precise either.